Hey guys, this is question MM033 of the Maths Methods Sharpen Study Guide. How to find when two simultaneous linear equations have no solutions. So first of all, we actually have to realize what no solutions means. And whenever we talk about solutions, we are talking about points of intersection between two graphs. So the way that we work out whether there is a point of intersection is to actually get it into a different format first. So at the moment, these graphs are very hard to read. They're very hard to see what's actually happening and what that would look like. So let's first of all actually get it into a different form. Y equals mx plus c we want. Y equals, not plus. So our first equation is 4x take ky equals k take 5. And what we want to do is we want to get it in this form here, y equals mx plus c. So we want to solve for y. So we get negative ky equals negative 4x plus k take 5. So, and then we divide by negative k on both sides. So we get 4 on kx plus k take 5 over negative k. So this is our m, or our gradient of the graph, and this is our c, or our y-intercept of the graph. Then we simply do this with the other one. So we have kx take 4y equals 9, negative 4y equals negative kx plus 9, and then we divide both sides by negative 4, which gives us k on 4x plus, take away 9 on 4. Perfect. So now we've got two equations in the same form. We can actually see what's going on. So we know that the gradient of this graph is 4 on k, and the gradient of this graph is k on 4, whereas looking at these two equations before, it was very difficult to tell that. So now what? We want to find the values of k for when these two equations have no solutions. And what it means by no solutions is no points of intersection. So if these two graphs want to axis together, no points of intersection would mean that they would have to be parallel, which means that their gradients would be the same, but their c values would be completely different, or not necessarily completely different, but different. If they were the same, if these two c values were the same, then they would actually be the same graph and have infinitely many solutions. So we want to find out when they have no solutions. So the first step to doing that is equating these two gradients together, because we know that they have to be the same gradient for there to be no solutions. So we equate the gradients. 4 on k equals k on 4, this bit here. We then solve for k and get 16 equals k squared, just by cross multiplying across there, which gives us k equals negative 4 and positive 4. So we know that when k equals negative 4 and k equals positive 4, the gradients of these two graphs are the same, but that doesn't tell us if they're going to be on the same line or whether they're going to have no solutions and be parallel. So we need to test this. So we know that our first c value is k minus 5 over negative k, and our second c value is negative 9 on 4. Now, if we plug a value into here for k, and it comes out that they're the same, then that means that they would be the same graph and have infinitely many solutions, which is not what we want in this question. So we want them to actually be different. So let's sub in negative 4 to start with. We get negative 4 take 5 over negative 4. And that means that we get negative 9 over, oh sorry, this is a positive, that's a negative k, that's a positive 4. And that's true, which means that when k equals negative 4, these two linear equations have infinitely many solutions, which isn't what we're after in this question. So we can discount that, and we sub in the regular 4, this one. So we get 4 take 5 over negative 4 equals negative 9 on 4, which gives us negative 1 on negative 4 equals negative 9 on 4, which is obviously completely different, which is good. That's what we want. So this means that the gradients are the same, but the c values, or the y-intercepts, are different when k equals 4, which means that the graphs are going to be parallel and have no solutions, which means that our answer is A, as I've circled over here.